Okay, great. I see the text, you can hear me. Okay, perfect. So I'll continue. So just go a little bit back. What I was saying before was the Python is actually, dominating the stage in terms of the usage in machine learning. But 2-3 years ago, R was actually in really bad spot in terms of the ranking. Python is still, on the first place as we speak now, taking from TLB website, but R is actually reviving itself back to being more prominent, more visible, and definitely this was the graph shows the new packages being developed and published to the CRAN repository, not the GitHub, only the CRAN repository because it's official. And you can see that there's been quite a lot of new development and going on in terms of the R. So both languages are definitely doing very well. R is literally, going back up. But where the difference between those languages is actually that Python is more interoperable, multi, platform, same as R, but it basically delivers and brings you much more in terms of connectivity, usage, programmability. And that's why Python has become the main language in terms of the Azure Machine Learning in Azure. Agenda for today is, I just want to give you a brief overview what Azure Analytic type of services you can get in Azure, what is machine learning in Azure and automated machine learning, and where to start, and we'll go through the demos. So the analytics family is literally, there's quite a lot of Spark literally going on right now. So you have Databricks, you have HD inside, and you have Synapse Analytics. All three are based on the Spark Analytics. Databricks is more like platform as a service. HD inside is literally everything open source and you have to build everything on your own. And you have Synapse, which is again as a service, which brings together enterprise data warehouse and big data analytics. And then you have also Azure Analysis Services, Stream Analytics, and Machine Learning Services, the one that we will be talking about today. So just a quick intro, a couple of applications where you can use or you can do with machine learning, so self-service, AI, image recognition, predictive maintenance, forecasting, e-commerce recommendation, classification, machine translation, and much, much more. Okay, not sure if you can hear me now. Okay, I presume you can. I don't hear you. Okay. I'm just gonna wait. The colleague is writing the chat and we can hear you. Okay, perfect. So the life cycle goes, you define the problem, you acquire the data. Okay, you design the model architecture, and then you do the training, which is this cycle here, and then you evaluate and you deploy. And all these 6 steps are available in Azure Machine Learning Services. This literally is much better when I run the PowerPoint presentation. But anyways, Azure Machine Learning Services literally can grab the data from SQL database, Cosmos DB, any type of data warehouse, data lake, blob storage, and what you do is you start preparing the data, you start building and training, and then you start deploying. So those are the main processes. In terms of the model lifecycle, in practice, which everything is available for you to use in Azure, is once you have the model trained, you can do the model registry. Once you have the model registered, you can start scoring and you can create an image, register an image, and you can deploy those images on different machines, different cloud services, whether it's Kubernetes, whether it's virtual machine. Everything can be literally prepared for you to start consuming the APIs or the model itself. And of course, you do the monitoring, whether it's monitoring of the accuracy of the model or monitoring how much you've already spent using that model. Okay, so I'm just gonna roll now the PowerPoint presentation and just give you an idea where we are standing right here. So probably I'm gonna lose the audio, but just I'm gonna give you this animation so you could get the sense. So you've seen the animation, and you can see that, you know, every model, basically you need to have features selected, different algorithms selected, and then you have to tune each feature with a different parameter, and then you get the result back out. So in this case, what we are talking about is actually we are talking about automated machine learning. Automated machine learning is a service which is available in Azure Machine Learning Services as a sort of quote-unquote black box service where you just, you know, put in your features, put in your data, and everything else is done for you. So it, you know, it grabs all the parameters, all the algorithms, and then it just iterates and get the best. So this iterative process is actually done for you as a sort of black box. The thing that basically stands in the back is more or less Scikit-Learn package. And then you have also TensorFlow, you have Keras, and other HTO, Onyx frameworks that basically help you build and find the best model for your problem. So the problems that we are having are usually classification problems, regression problems, clustering problems, but you can also do the dimensionality reduction if you are, you know, having a lot of data, or you just want to, you know, get the data set smaller, or you want to do some sampling. So all these require different models, different type of data, and I'm definitely not going to go into that, but, you know, this is just to give you an idea what type of processes, packages, languages, and algorithms are in behind. So what is automated machine learning, in fact, is it's just sort of like a black box that picks algorithm and do all the hyperparameters for you and generates a model for the deployment. This model, or the best model, can later be either downloaded, customized, analyzed for you to do the rest of the analysis. Couple of, you know, steps and parts. You probably have seen this a lot, many times. Just want to quick recap. So you have data, everything regarding the data. You have the features, type of the feature engineering that you have to do. Then you have to do the algorithm picking, tuning, ranking, and of course explaining. Explaining part is quite cumbersome in terms of black box algorithms versus the glass box algorithms. Glass box algorithms are the ones that are easier to understand, are more easier to interpret, are more easier in terms of not hidden features, but more like if I take variable A and deduct it by n, the other one will also have some effect of it. So this is very similar to, let's say, regression or decision trees were easy to understand versus, so these are the glass box. The black box are the ones that we usually don't understand what's going on in the back. So again, this would be animation where you would get a data set. So I'm probably just going to run this so you can. So you could see that, you know, every time you would have the same data set, you would start taking one trained algorithm and do all different hyperparameters, do all the calculations and get model 1, model 2, model 3, model 4 out of it, which is, again, you know, time consuming, and there is a lot of repetitive work and manual work, which automated machine learning gives you is, you know, this basically is done much faster, much easier. At the end, you get much more time savings and cost savings, and of course the best model is selected for you. And also all the metrics, all the exit variables, all the constraints are again put in the same aspect, which means that they can be comparable, and it's much easier for you to decide which model performs better. So at the end, again, animation, what you do is basically you select the correct model. I'm just going to run the animation. So what you've seen is actually you've taken, the input data, and then this automated machine learning is actually what it's doing is taking the best set of the data, the best model, and then outputs the best model, which has, the best metrics. So this is actually, what is available for you once you go into this automated machine learning part of the Azure Machine Learning Services. I've mentioned black box a couple of times. So what does this mean is actually you get a lot of models as seen on this right-hand side screen with the metrics and the best metrics for you to choose. Again, you can click on that, you can download, and you have basically everything available immediately. So immediately it means like half an hour, depends how much you want to train the data. You don't really have to care about any configuration, any Python scripting, because you just basically go through a menu and select stuff. At the end, you also get the result, so the dashboard, where you can see each run in particular. You get different charts where you can, see which metrics performed better, and also the metrics for the particular run for you to decide which model to select. There's also additional capabilities when we are talking about our Azure Automated Machine Learning. You have different scenarios, you have much improved integration with the machine learning, Azure notebooks, Jupyter notebooks, and also training compute, which is available for you as a separate resource where you can just train the model. You can boost the virtual machine, which can be much beefier versus the one where you can consume the model because you don't need that much resources. So all those things are decoupled in terms of the CPU, the compute, and the store, the database, and also where you put the model. Then the second part is so-called the visual interface, which supports not only Python but also R. And this is actually sort of drag and drop type of machine learning experience. So once you create this path, as you can see, in this case, it's a regression problem of the same use case as seen before. So how to predict the model, the automobile price. You take the model, you take the data, and then you start doing the data selection. You find the best algorithm, you train the model, and then you do the scoring and validation. And at the end, you get the model which you can easily deploy. Again, you spin up a virtual machine where you can run then this particular API as a model for you to score or to predict. There is also a very rich support in terms of the community, in terms of the Microsoft. There is also a marketplace where you can publish your solution or download the solution. This is definitely great for those who are getting into this, not because it's not that complex, but because of the visual aspects, and you have these assets sort of grouped where you can see what you want to do. The second part are the notebooks, which are, we've seen the notebooks gazillion times. For instance, this is the Netflix story that how Netflix actually started everything just in using just Jupyters. The best part about these notebooks is they're repeatable, they're easy to manage, and they're very much flexible. So you can, write code, type some documentation, markdown, you get the results, you get the plots, you can store, you can write, etc., etc. Again, everything is in terms created to be more readable, more manageable, and more visible. And then you also have the virtual machines. So you can have virtual machine to where you can run your notebook or a Jupyter lab. So this would be a dedicated virtual machine for machine learning. Again, everything in the scope of the machine learning services. It's fairly easy to just basically click and start working on. You can do continuous delivery and deployment, especially with the models and also with the images. And then you also have the Git integration. So if you want to push the data, whether it's DevOps, it's Git, everything can be done. You also have different pre-prepared environments, and also extensions are available for you. So you have 4 different languages like Scala, R, Python, and then you also have different frameworks where you would have different flavors of, let's say, Python and stuff like that. So again, this is another aspect of that. And then this is SDK for Python. This was built 2 years ago and it's constantly improving. This is where basically Python meets Azure Machine Learning packages. So you would have like 2-3 different Python packages where you can literally do anything. So in terms of building and running machine learning workflows, you can do logging, you can do monitoring of your machine learning modules, you can train the model, basically anything. So all this was basically created for you to just, code. If you don't like coding, you can go, with that visual thing where you just drag and drop all the assets and connect the dots and get literally the same thing. But this basically gives you much more operability and much better, in my personal opinion, much better experience with the work. There are a couple of namespaces which are extremely useful, like workspace, experiment, run, model, data prep, and stuff like that. So all these are there for you, to just import if you're using Python, and then start running either the modules, the experiments, all the configuration, and also web services. So this is interoperable with, let's say, Scikit-Learn, with Pandas, with Keras, with TensorFlow. So all this is literally, the packages can communicate with each other, whether you create one artifact in Azure ML and then you can put this back into Scikit-Learn or vice versa. Then there's also feature engineering, where you can basically transform the features and basically helps you identify the model. And you also have so-called tuning of these parameters. Again, these are parts either of the code or the features which will help you do all these tasks. Then there is this model explainability and interpretability, which is fairly new concept. Maybe last year, 2 years have been emerging. This basically derives from the ethical aspect of artificial intelligence and machine learning, and also from the aspect that black box algorithms are hard to understand. So there has been Shapley or Lime, the famous Lime packages available for you to start explaining why a particular feature is important or why a particular variable has played significant role when it comes to particular, let's say, prediction of the model. So this will definitely give you much more aspect and understanding why the model is performing the way it is. So everything actually is available for you in Azure Machine Learning and also in Python SDK. There's also time series support. So for those who are into analyzing time series, there's a lot of features available for that as well. And also, as I said at the beginning, model deployment and frameworks and environments are also part of this world where you can start working on that immediately. So when I say predefined Azure ML environments, this means that you have, if you're running, let's say, a lot of GPU intensive computations, there is an environment for that prepared for you, which means that it will have a GPU, much more beefier GPU with particular, let's say, packages pre-installed. So you just sort of provision that environment and you're ready to go. You can also create a custom environment, which is, again, super fine if you want to do the fine-tuning. Then there's also model frameworks available like H2O, Onyx, PySpark, Pytorch, and many others, which means that they are predefined and already compatible with Azure ML and Python, so that you don't have to worry about versioning and stuff like that. So you just grab a framework, either you start working on it or you import the model in that framework. So whether you've created, let's say, PySpark model somewhere in your local machine, you can also upload the model in this framework and start, running or consuming the model. You also have model versioning and artifacts, and again, model endpoints and consumption or consuming through the APIs. All this is available. Again, model versioning endpoints. This is something that you would either need to go hands-on with Python SDK. It's not, click and drop and stuff like that. Okay, so I'm just gonna go now into my demo. So first of all, I will look into, so I hope you can see my screen. Once you log in into your Microsoft Azure, what you do is you go and search for machine learning. So machine learning is as a service, and you create a new directory or a new workbench. So this is something that I've already created. So it just gives you, all the URL, the vaults and everything. Keep note that there is this config.json file, which is available for you if you want to run Python code locally or on different hosts. You would definitely need this JSON file. So in this JSON file, I can just show you, it's nothing really that fancy. Okay, I'm not sure if the file will be. Okay, so this is something, as you can see, probably not. Zoom in. Yes, should be much better. So you just have subscription ID, resource group, and workspace name. So it's something that you don't really have to care about. Everything can be downloaded here. So this is something that you would need if you would be running the resources available in Azure from your host machine. So, okay, you launch the studio and you come to a studio, and the studio looks like this. So on the left-hand side, you would have the notebooks, automated machine learning, the designer, something that we've already covered. And then you have assets broken down into data sets, experiments, pipelines, models, and then you can do the manage the compute and data store and linked services and data labeling. So again, everything is sort of decoupled, which means that if I'm running this, for instance, so this is a Jupyter notebook, I am running it on a particular instance. I can create a new instance if I wanted to run this model or this prediction much faster. I can, just spin up a much beefier engine. Again, this is up to you. Now this is super fine because you have the compute right here. You can create new compute. it's going to be much easier, much faster, and also you have the data store, as I said, decoupled. Okay, so this is something that you can start working on that. But let's say that your data is, so let's say this is my data. Just gonna try to make it a little bit bigger. Okay, so let's say that either my data is here or my data is somewhere on the blob store, doesn't really matter. What I can do is I can go and without using this web interface, I can go into, let's say, Visual Code, or I can use, I can go and use, you know, preferred Python language, Python IDE, or I can also spin up a local Jupyter Lab, for instance. So in this case, this is running locally. So as you can see, this is my local host. And what I've done is I've basically pip installed Azure ML and ML Core. Again, this is something which, you know, you can do later. And I've said, okay, deploy this package. And remember when I said the subscription ID, resource group, and workspace name, you can use that here and run this. Yes. Yes, I can hear you. Okay. Yes. Thanks for letting me know. Should be fine, right? No, it's so big I cannot read. Okay. You're welcome. Okay, so you basically install, so this is now running on my local machine, and with this subscription ID resource group workspace name, I can get, for instance, the data that I've already either imported on my blob store or imported in my workspace, Azure Machine Learning workspace. So just a couple of, you know, lines of code, and I can, bam, see my Ozone data, which again now running locally, but the data is in the on the workspace in the cloud. So again, I can switch here. Now I'm in the cloud, and you can see this is the Ozone dataset. I'm just going to make this slightly bigger. Okay. Hope you can see. Okay. And you can see that literally this is the same data set as this one. Again, this is, you know, in the in this case in my web browser. But again, if you feel uncomfortable writing code here, with simple code like this, you can start, you know, running this locally. And again, as you can see, I've just put the data set to pandas and start, you know, writing, for instance, pandas described, and I can immediately get, you know, on with different R packages or frameworks on my local machine. So this is something, you know, when you are, you know, building this, you can just, you know, keep that in mind, that it doesn't really matter where you are. You can always, you know, connect to these resources from the local host. Okay, when I'm in Azure Web Services, I can start, you know, using, so this is basically Jupyter Notebook, and I can start, you know, doing all the cell operations. I can add cell, I can clear cell, I can even run this cell, for instance, as you can see that I'm running a dataset and Scikit-Learn support vector machine, and then I can see the, for instance, the data and get the training set, fairly simple, and then see the explanation of this particular prediction. So in this case, I'm using the Mimic explainer, which is available as a part of the Scikit-Learn, and I can see the global explanation, and then I can print all the results. So again, this is something that you can easily run either on your local machine or in the cloud. And I'll just go here and immediately rerun this to visualize it. Again, this is interpret, and you can either click here and it will basically create a new tab, a new widget where you can then explore the data. So this is part of this when I was explaining about the interpretability and explainability. So this is part of that. If I would be zooming out this view, I would have this also available here. So I'm just putting it on the new tab for you to see. And now I can explain and explore how my model was performing, explore the data set, feature importance, and also do what-if analysis. So again, this is something which was done fairly easy. Again, you can also do this out of the box. If you go to automated machine learning, for instance, and you run this on a particular model, you would get the same, basically the same results back. And how do I do that? Let me just go automated machine learning, and I can click. So these are my experiments. As you can see, some have failed, some have run successfully. I see how long they've been running and stuff like that. So if I click on a model, and if I want to explore a particular model, I can see when the model was running, how long it was running. I can click here on the model, and you can see that this is automated machine learning, which means that Azure machine learning services have, based on the inputted model, which is fairly small, have created the best explainer. So in this case, it's the XGBoost classifier. And if I click here on the best model, say view explain, I will get the same explanation as on this widget that I've been created here. So again, different data set, keep that in mind. But as you can see, model performance, data set explorer, feature importance, all this is, again, can be created equally by either running this code or by just going into automated machine learning and click on the model and say, okay, now I want to understand why this model has performed in such way. You can also do edit cohorts, which means that you have subgroups of the data and you want to see either comparison of the data, again, based on the type of the data and the type of the prediction model, algorithm. Either you can do that or not. In this case, you can do, and you can also compare the cohorts as type of the result set. So again, as you can see, I can then click and get subsets. I can also view the metrics and I can play with that. You can also see all the metrics that are available. You can also see the data transition, how the data was created, and then the tests. Okay, in this case, I don't have any tests. Logs, images, if I create an image, and you can also see child runs, for instance, which means that for a particular run, you could have also child runs if there are, any hyperparameter tuning needed, stuff like that. So again, everything is created for you. And once you've decided with this automated machine learning that you want to deploy a particular model, again, I'll go back. So this was my model. If I decide, I can go edit, submit, and I can deploy this model. Once I deploy the model, whether it's automated machine learning, whether it's through my notebooks, through this part, so notebooks or this, all my models will be visualized here, and all my endpoints will be available here. So in this case, this is an endpoint which also would need to have a virtual machine as a compute provider available. So I would need to have, probably this one is not running right now, but I would need to have a virtual machine in the back for this model to be consumed. And again, this is something, if I click on, I can then input the data and get the prediction for that data set out of it. So again, this is fairly simple. You don't really have to do much of that. Once you've created that, you're ready to go. I also mentioned the designer. So the designer is the one where you basically just do drag and dropping. And this was run maybe half an hour ago, so I'm not going to run this because it takes some additional time. But you can see that it has completed. Normally everything is green. And once I've once I've evaluated the model, I can always click on it. I can also push this model to be published either as a pipeline or publish as an API. So if I click here, I can create an API, fairly simple, and it will ask me, where do you want to go? How do you want to, create it? Pipeline in this case is just, the process where you get the data, all the transformation, all the training, etc., etc., and publish itself as an endpoint is sort of like a URL, secured URL through as an API where you just input the data and get the predictions out of it. So fairly simple. Again, in this designer, what you do is basically you drag and drop data like this, and you see you have these connectors, and you just sort of connect those. It's kind of hard for it's not going to be connected now, sorry. I'm going to do like this, and you can see, you just sort of connect everything together and you are ready to go. The best part for this is also you can preview the data. So I can right click and get data preview if you wanted it to see. You also get a quick profiling of the data, which is again super fine, just to have the sense of the data and stuff like that. But otherwise, you can also do the profiling through this data transition, select features, statistical function. This is also good for data profiling. Okay, so we've looked into the notebooks, automated machine learning, and designer. With the automated machine learning, with the notebooks, you can also view the data. So we've seen that. You can also, any given time, whether you decide to create a Jupyter notebook, you can also edit it in the visual code. So in the visual code, what you need to do is you click on the visual code, and bam, if you have visual code already installed, you will have the visual code launched, and you will see now. Okay, maybe I don't have all the I would need to I would need to have some additional plugins installed, but anyways, okay, my bad. This is wasn't intent to show this. So you can see you have the Azure plugin where you basically connect, and you can see all my resource groups, and also there is at the bottom there is the machine learning, my workspace, and just gonna go do like, not sure if you can see. You can see all the data sets, experiments, notebooks. So basically you can also edit your notebooks in the Visual Code Launcher. So again, very easy and straightforward. So I'm not going to run another notebook because they're fairly the same. Basically you just write your code, but then you can also, I said, you have different languages also available. So again, based on the compute that you've created and the framework you've used, you also can select between different languages. So in this case, I'm using Python, but you can easily go with R, you can easily go with Pytorch, TensorFlow, which means that those kernels, so we are talking about notebook kernels, will have all those packages already predefined. You can also, for instance, you can also upload on the files. You can always upload the file. So you can upload if you've already written something, you know, on your host or local machine somewhere else. You can also upload. And if there is need for any particular languages, or if the versions are not compatible, Azure Machine Learning Services will definitely understand this and will try to help you by giving you the right either framework or the right set of packages. There's within the compute part, there's nothing really that, so you can have the compute cluster. So if you don't want to have one instance, you can have the cluster. You can also have the inference clusters. In this case, you can connect either to or deploy to Azure Kubernetes Services, and this is certainly great for running, for instance, type of Monte Carlo simulations, because you can, you know, spread out immediately to different or multiple cores or virtual machines, or in this case, microservices as a Kubernetes services, and you can also attach compute. So which means that, okay, I have a couple of virtual machines and I'm just going to attach those into my cluster pool, and I can easily use those any given time if it's available. And then you have the data store. So you can see that I have a couple of different containers. So I have blob store container, and everything can be stored there and sort of being represented here as well. You can also do that if you decide to write the code. You can also, so as I've shown here before, you can also, you know, instant, you can say from Azure ML, you know, import blob store, and you can go and start getting the data from the blob store as well. So those Azure ML core packages can also communicate with your blob store. Just keep in mind that then you have to have the resource group created, Azure login authenticated, and then you're ready to go. And also you would need to have on your store account, storage account, a couple of permissions set correctly, but otherwise you can basically, you know, connect everything together and it should work perfectly fine. So this is actually what's available for that. If you want to build your whole artifacts of the models, you can also, any given time, you can download the model, as I said, and you can get the artifacts for a particular model as well. So in this case, it's just a pickled model, but if you would have, or if you would be writing Python code in this way, that say, okay, just also give me the YAML file for all the dependencies or all the data sets, you can also have the artifacts written here, and you would have the, that also available for you to either download or to publish somewhere else. The explanation part is also something, and the fairness part, those two are available through automated machine learning and also available through Python SDK. So either way, which one you're using, it's up to you. But if you'll be using through Python SDK, you would also have to sort of import the functions to use fairness and explanation. So explanation we've seen before in this widget. This is part of the explanation where you're trying to explain why the model performed in such a way as it was. Fairness, again, is a fairly new package. It has been in preview for at least a year and a half now. Don't ask why, but it is fairly new and very user-friendly and usable. And environments, we've already discussed that. I just want to briefly show you. All these are environments available for you. You can see a couple of those tags telling you what operating system, if there are any differences, if there are any special RAM, CPUs and stuff like that available for you. But you can also create a custom environment, up to you, which can be either image Docker, or it might have a particular set of, let's say, Python packages that is strictly used in your, let's say, enterprise. And the pipelines is something where you just basically sort of create, let's say, quote unquote ETL, or sort of like a task of jobs for your model to be consumed or the data to be prepared. I think I've exhausted all the bits and parts in this part, so yeah, let's just go back to the PowerPoint presentation. I think we've covered that part as well. So yeah, this is probably the last slide. So the key takeaways is automated machine learning is part of this black box new generation type of machine learning. I would strongly recommend you that you use it, but don't get too much hang of it, because sometimes it's hard. It really is sort of like you have to calculate the payoffs, whether you want to have the model which has slightly less accuracy but much more explainability versus zero explainability and much better, let's say, accuracy or precision code. Doesn't matter. So this is something that you either need to keep in head. The other thing is that I usually say go and use automated machine learning and just see and take top 5 algorithms and then go into these algorithms and start playing with this, whether it's an assemble model, whether it's a from a particular, let's say, Python Keras package. Just go and then study that model, why it performed this way. So for me, automated machine learning is sort of like a pointer in which direction I want to go, and then I go into and start using different Azure machine learning frameworks or computations, and start basically building from there on. Also, notebooks are really great way to start, connecting people in your enterprise. So just don't deliver just the code, deliver the whole experience, the whole story. How you started with all the documentations, and also the artifacts are always available for you. And also, if you're new in this ML experience world, Azure Python SDK is fairly straightforward to use and easy to combine with other Python packages. So thank you very much. Feel free to drop an email or get in contact with me. And just 4 more minutes for questions. Yeah. Okay. Okay. You're welcome. In person, yes. Thanks for having me. You too, and have a beautiful afternoon at the conference. Yeah, welcome. Cheers. Bye.